Hi, guys. Welcome back. We're ready to learn more about our solar system. More about our solar system. Today, I'm just going to read you a little bit from our science source book and a little bit from our What Your Third Grader Needs to Know. And basically, what it's going to be is a review of what we covered last week. And then, so this is going to be a really short video from me, but there is also another video which gives a lot of information about the sun and the planets. And I am going to attach that one as well. So you're going to watch both of the videos today and move that down a little bit. Okie dokie. Our solar system includes the sun, 8 planets and their moons, comets, large space rocks called asteroids, dwarf planets, and small space rocks called meteoroids. Meteoro, meteoroids. Blah, meteoroids. Beyond our solar system are stars and groups of stars called galaxies. Does anybody remember what we used to so that we would remember the names of the planets? My, Mercury, very, Venus, excellent, Earth, mother, Mars, just, Jupiter, served, Saturn, us, Uranus, nachos, Neptune. My very excellent mother just served us nachos. If you remember that, you can put the planets in order. The sun is an average sized star at the center of our solar system. Everything in the solar system revolves around the sun. Everything is kept in orbit by the pull of the sun's gravity. The sun rotates on its axis. The sun completes one rotation in 25 days. One rotation of Earth takes less than 24 hours. Gravity is the force that pulls objects toward each other. All objects produce a force of gravity. The more mass an object has, the greater its force of gravity. The sun has much more mass than Earth, so the sun's gravity is much greater than Earth's gravity. As the distance between the objects increases, the force of the gravity between them decreases. So the farther apart they are, the less the force of gravity. If Earth were farther away from the sun, the force of gravity between Earth and the sun would be less. The sun's gravity keeps the planets and the other objects in our solar system in an orbit around the sun. Remember, we talked about an orbit is the path that one object takes around another object. It's a revolution. If it were not for the sun's gravity, planets and other objects in the solar system would speed off into outer space. The gravity of a planet keeps the moons in orbit around it. So that was gravity, which we learned about last week. And I dropped the pencil a couple times so that you could understand how gravity works. Now, the next thing, that's not it. We're going to read out of what your third grader needs to know. Again, we're talking about the force of gravity. What keeps the moon orbiting around the Earth instead of floating off into space? Gravity. Gravity is a force between bits of matter, attracting every bit to every other bit. Gravity is a force that keeps our feet on the ground. You may not feel it, but gravity affects you all the time. When you throw a ball up into the air, what happens to that ball? Right, it comes back down. No matter how high you throw the ball, it always comes back down. The gravitational force between the Earth and the ball pulls the ball down to Earth. If it were not for the force of gravity, the ball would just keep going up. In fact, without gravity, if you jumped, you would just jump right out into outer space. Earth's gravity pulls on the moon, and the moon's gravity pulls on Earth. Those forces keep the moon in the orbit around the Earth. In the same way, the sun's gravity pulls on Earth and other planets and keeps them in orbit around the sun. The power of the pull of the gravity between the objects depends on a couple of things. Number one, how far apart the objects are from each other, so the distance between them. The greater the distance, the smaller the gravity. And the other thing is the mass of the object. No matter that is how much matter each object contains. The greater the mass, the greater the gravity. Objects that are close together and objects that have lots of mass attract each other strongly. Things that are far apart and things with small mass attract only weakly. Let's think about what these rules mean. If you were on the moon, you could jump much higher than you can when you are on Earth. You could jump high and you could slam dunk a basketball as easily as a 7-foot tall basketball player. Why? Since the moon is much smaller than Earth and contains much less matter than Earth, its gravitational pull is weaker than Earth's gravitational pull. With gravity pulling more weakly, you can jump higher. You would even weigh less on the moon. We found that out last week, didn't we? Only about 1/6 of what you weigh here on Earth. Can you figure out then how much you would weigh on the moon? Well, we figured out if you weigh 60 pounds here on Earth, you would weigh just about 10 pounds on the moon. Although the moon has much less gravity than Earth, its gravity still affects us. The gravity of the moon, with just a little help from the gravity of the sun, pulls on the waters of the oceans here on Earth. The gravitational pull causes the tides, excuse me, which are the regular patterns by which the water's ocean level rises and falls. If you've spent a day at the beach, you've probably noticed the difference between low tide and high tide. At low tide, you can play on a broad, sandy beach. But when high tide comes, the ocean's water level rises and covers part of the beach, leaving you less room for you to play. So if your sandcastle gets washed out by the tide, blame it on the moon. Astronomers think that there are places in the universe where the force of gravity is so strong that it captures anything that comes near it. These super dense places pull in everything. Nothing can escape them. What do you think those are called? Some of you know. Their pulling power is so strong that even light cannot escape from them. And that's why astronomers call them what? Black holes. You got it. Astronomers call them black holes. The gravitational pull of a black hole is so strong that nothing escapes it. Everything is sucked into a sucked into a black hole. Okay, that's all I have for you today from me. But what you can do is also watch the video that I'm going to attach to this video. And then there is another YouTube video that I'm going to attach for you. You guys have a great day. And we'll be back tomorrow when we're going to work on a lab. What we're going to do with that lab is we're going to figure out weight on other planets, our weight on other planets. But for today, you have a great afternoon, and I'll see you tomorrow. Bye.